This is LeetCode problem number 50, power of x comma n. We want to efficiently calculate x to the power of n. Let us look at an example. Let's say we want to find what x to the power of n is for when it's 2 to the power of 11. The brute force way to do this is to do 2 times 2 times 2 dot 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 11 times. This is O of n, which is really slow if you have the constraints being 2 to the power of 31. So how do we do this more efficiently? Let's look at 2 to the power of 11 again. We can break this up into subproblems. So 2 to the power of 11 is the same as 2 to the power of 5 times 2 to the power of 5 times 2. And 2 to the power of 5 is the same as 2 to the power of 2 times 2 to the power of 2 times 2. Same for this one, and this 2 drops down. And how we solve 2 to the power of 2 is the same thing. We could break it up into 2 to the power of 1 and 2 to the power of 1, which is just 2. Same for this, 2, 2, and 2. And it's going to be the same here, and this 2 drops down. So to solve 2 to the power of 11, we can break it down to 2 to the power of 5, 2 to the power of 2, and 2. We only need to solve this once each. So why is this more efficient? Well, we only need to calculate 2 to the power of 5 once, because these are the same values. We can use what we calculated here to fill this up. Therefore, we don't need this entire subtree. And likewise, as we recurse down the levels, we only need to calculate what's on the left side of this tree once, and these could be trimmed off. So essentially, we're just calculating 2 to the power of 11, 2 to the power of 5, 2 to the power of 2, and 2. And this effectively reduces our runtime from O of n to just whatever this number of levels are, which is O log of n. Because at each level, we are effectively dividing the n by 2. Another thing that we need to note is that x to the power of some negative number is the same as 1 over x to the power of n. So when we have negative n's, we just calculate them as if they're positive by using absolute value of n. So power of x comma abs of n, and then return 1 over that, which is equal to power of x and n minus. Okay, let's look at the code now. Our end goal is to recursively calculate what the x to the power of n is. So let's define what this function does. If you have x is 0, 0 power of n will always be 0. So you return 0. If you have n is 0, x to the power of 0 will always be 1, except for when x is 0, and that was handled above. So this will always return 1 in this case. So now we need to find the factors of the x to the power of n. We do this by doing n over 2. We are splitting this n by 2 like we did before in the diagram of the tree, and we need to know if there is an extra value, an extra 2 to the power of 1. So let's say extra is 1 for now. If n mod 2 is 1, then extra is x. So we're timesing another x to it at the end. This is for an odd number power. Odd power. So we have an extra plus x at the end. Times x at the end. And our result again is the factor times extra. Remember when we did the 2 to the power 5 times 2 to the power 5 times 2. And return result. So this function is recursively breaking down this 11 into subproblems. We're breaking down 11 to 5, 2 5s, and 1 2. We calculated the factor once, 2 to the power 5 once, and we only recalculate it again. We already have factors, so we just times it by itself, and then times an extra 2 if it is needed. In this case, if it's 11, there's an extra 2 here. And then we return the result of that. And yeah, so that's the recursive function. And now we just need to handle the edge case where n is negative. So if n is negative, we return 1 over the answer. Otherwise, we just return the answer. Okay, so now let's submit this code. It passes. So what is the complexity of this code? The time is O of log n because it depends on the number of levels that we're traversing, and there's only, at each level, it's n is divided by 2 until it's 0. So there's only log n time complexity. And as for space complexity, it's also log n because our space depends on the recursive depth. And in this case, it's taking the left path of the tree. And there's only, this depends on the number of levels in the tree, and that's log n.